How Japan constructed a bullet train tunnel deep under the ocean. Imagine traveling at more than 250 kilometers per hour beneath the ocean floor. No sunlight, no windows, just a high-speed bullet train racing through a tunnel surrounded by millions of tons of seawater. It sounds impossible, but in Japan, impossible engineering projects often become reality. Today, we explore the incredible story behind one of the world's most ambitious transportation projects, the construction of Japan's deep undersea bullet train tunnel. A mega engineering achievement built to connect islands, survive earthquakes, resist extreme water pressure, and carry millions of passengers safely beneath the sea. This is the story of how Japan constructed a bullet train tunnel deep under the ocean. Japan is a nation made up of islands. For decades, moving people and goods between these islands depended heavily on ferries and airplanes, but the ocean separating them created a huge transportation challenge. Strong winter storms often disrupted ferry routes. Air travel was expensive and vulnerable to bad weather. And with Japan's economy growing rapidly during the 20th century, the demand for faster and more reliable transportation became urgent. Japan needed something revolutionary. The answer was bold: build a tunnel beneath the ocean itself. Not for cars, not for ordinary trains, but for high-speed bullet trains traveling at incredible speeds. At the time, many experts believed such a project would be too dangerous, too expensive, and technically impossible. But Japan decided to attempt it anyway. Constructing a tunnel under the sea is completely different from building through mountains or flat land. Engineers first had to study the seabed in extreme detail. They drilled deep exploratory holes into the ocean floor to analyze the rock layers below. What they discovered was alarming. Some areas contained unstable rock. Others were filled with underground water channels under enormous pressure. If excavation went wrong, seawater could burst into the tunnel instantly. Even a small leak could become catastrophic. To reduce risk, engineers decided not to build directly in the seabed itself. Instead, the tunnel would pass deep beneath the seabed through solid rock below the ocean floor. This meant excavating through incredibly difficult geological conditions for years. Massive tunnel boring operations began from both sides of the sea. Workers drilled through volcanic rock, fractured stone, and water-filled ground using specialized excavation machines and controlled blasting techniques. Progress was painfully slow. In some sections, crews advanced only a few meters per day. Water leaks became one of the greatest dangers. At certain points, high-pressure seawater suddenly burst through cracks in the rock, flooding excavation zones. Emergency sealing operations had to be carried out immediately. Workers injected cement and chemical grouting materials deep into the surrounding rock to stop water infiltration. Thousands of tons of reinforcement material were used to stabilize weak areas, and because the tunnel stretched for dozens of kilometers beneath the sea, ventilation became another major challenge. Fresh air had to be constantly pumped underground for workers and heavy machinery. Temperatures inside the tunnel also became dangerously high in deeper sections. Despite all of this, construction continued year after year. Japan sits on one of the most active seismic zones on Earth. This meant the tunnel had to survive powerful earthquakes beneath the ocean. Engineers designed flexible structural systems capable of absorbing seismic movement. The tunnel lining was reinforced with thick concrete layers and steel support structures. Advanced monitoring systems were also installed throughout the tunnel. These systems constantly measure vibration, water pressure, structural movement, and seismic activity in real time. If an earthquake is detected, bullet train systems can automatically trigger emergency braking within seconds. Safety became the highest priority because beneath the ocean there is almost no room for error. Building the tunnel itself was only half the challenge. The next step was transforming it into a high-speed railway capable of carrying bullet trains safely at extreme speeds. Tracks had to be installed with incredible precision. Even tiny alignment errors could become dangerous at high velocity. Engineers used advanced laser measurement systems to ensure perfect rail positioning. Special vibration reduction systems were added to maintain stability and passenger comfort. Emergency escape routes, fire protection systems, drainage tunnels, and ventilation shafts were also integrated into the design. In an emergency, passengers would need ways to evacuate safely beneath the ocean. Every detail was engineered carefully. After years of excavation, the tunnel sections digging from opposite sides finally met deep underground. It was one of the most emotional moments of the entire project. Workers who had spent years underground celebrated as the final rock barrier was broken through. The impossible tunnel was finally connected, but even after excavation finished, years of testing still remained. Engineers conducted pressure tests, water leakage inspections, structural analysis, and high-speed rail trials before the tunnel could officially open. Everything had to perform perfectly, because millions of lives would eventually depend on it. When the undersea bullet train tunnel finally opened, it transformed transportation in Japan. Travel times between regions were reduced dramatically. Routes once dependent on weather-sensitive ferries became reliable year-round connections. Economic activity increased, tourism expanded. Freight transportation became faster and more efficient. But beyond transportation, the tunnel became a symbol of Japanese engineering ambition. A project many believed impossible had become reality. And beneath the ocean, bullet trains now travel safely every single day. Engineers around the world studied Japan's undersea tunnel project closely. The techniques developed during construction helped influence future tunnel projects across the globe. The project demonstrated how modern engineering could overcome extreme geological conditions, immense water pressure, and seismic risks. Even today, constructing tunnels beneath oceans remains one of the most difficult engineering challenges on Earth. Yet Japan proved it could be done, not with shortcuts, but with decades of planning, precision, and persistence. Deep beneath the ocean floor, surrounded by rock, darkness, and crushing pressure, high-speed trains continue racing through one of humanity's greatest engineering achievements. A tunnel once thought impossible now connects millions of people beneath the sea. And it stands as a reminder that some of the world's greatest structures are the ones we never even see. Because hidden below the ocean lies one of Japan's most extraordinary engineering marvels.